In the last video, we left off with doing some examples in which you were deciding whether functions were, where there's some tables were linear, exponential, or neither. 6, 9, and 11 all came out to be neither. So now we want to look and see what we can notice. So if we look at number 6, we can see that it goes 5, 10, 16, 23. So to get from 5 to 10, we added 5. To get from 10 to 16, we add 6. To get from 16 to 23, we add 7. Then we can notice in number 9, to get from 18 to 14, we minus 4. 14 to 8, we minus 6. 8 to 0, we minus 8. And from 0 to negative 10, we subtract 10. And then in number 11, to get from negative 3 to negative 4, we minus 1. To get from negative 4 to negative 3, we add 1. To get from negative 3 to 0, we add 3. And to get from 0 to 5, we add 5. So we can see that our change in all three of these sequences is not constant. It's changing. But what do we notice? Could we come up with the fifth term for number 6? And we can, but as you can see that we can add 8 to 23 to get 31, and that'd be the next term. In number 9, we can find the sixth term by subtracting 12 from negative 10 to get negative 22. And in number 11, for number 6, we can add 6 so that, not 6, sorry, we can add 7 to 5 to get 12. So while the change isn't constant, there is a pattern. We notice that there's a pattern to get what we're going to add. And we can see for number 6, that pattern is each time we increase what we add by 1. In number 9, we increase what we subtract by 2. And in number 11, we're adding 2 to what we add each time. So we notice that the second difference, or the second change, is constant. And that's shown down here. We're adding the same amount to the amount of change. Having a second change that is constant means that our second difference is linear. And that's what's important to see, that the first change is changing, but the second change is constant. And this is going to tell us something very special. Now let's look at these examples. They want us to use the function rule to complete the table and then find the first difference and the second difference. So the first difference being that first change, the second difference being that second change. In number 1, we fill in their table. So for term 1, we get 8. For term 2, we get 11. For term 3, we get 16. For term 4, we get 23. For term 5, we get 32. All we're doing is taking this n value and plugging it in. So we're doing 1 squared plus 7. And then we're doing 2 squared plus 7 and 3 squared plus 7. Notice each time I'm using parentheses to plug in. That's how we're getting those f of n numbers. We can see that get from 8 to 11, I'm adding 3. To get from 11 to 16, I'm adding 5. To get from 16 to 23, I add 7. And from 23 to 32, I add 9. And again, if you're having trouble remembering how to do that, you can always do 11 minus 8, 16 minus 11, 23 minus 16, and that will tell you all of those numbers. Once you've done that, you can see to get from 3 to 5, you add 2. To get from 5 to 7, you add 2. And to get from 7 to 9, you add 2. So you're finding that that second difference is constant. You'll do the same thing for 2, 3, 4, 5, and 6. You'll plug in your n values to find your f of n. So let's do number 3 together as well. So we're going to do, for the first one, we're going to do 2 times 1 squared. So order of operations, start with 1 squared. 1 squared is 1, times 2 is 2. Then we're going to do 2 times 2 squared. Again, 2 squared is 4, times 2 is 8. Then we're going to do 2 times 3 squared. 3 squared is 9, times 2 is 18. And then 2 times 4 squared. 4 squared is 16, times 2 is 32. And 2 times 5 squared. 5 squared is 25, times 2 is 50. To get from 2 to 8, I add 6. To get from 8 to 18, I add 10. To get from 18 to 32, I add 14. And to get from 32 to 50, I add 16. I'm sorry, 18. So now I want to look and see, how do I get from 6 to 10? Well, I add 4. 10 to 14, I add 4. 14 to 18, I add 4. So I'm seeing I have a constant second difference. You try and finish the rest of this page.